All right, so we're starting our year in section 1.1. Today we're learning about expressions and variables. Expressions and variables. So to start off, we're just going to go over a few terms real quick. Couple terms. One term is a variable. What is that? Well, it's a letter used to represent one or more numbers. Basically, I can assign it whatever value I want. Now, in an equation, there's only one value for the variable that will make the equation true. But in expressions, we can give the variable as many values, different values as we want, and evaluate. The next term is a variable expression. Okay, so we're focusing specifically on the word expression. Well, what is that? It consists of numbers, variables, and operations. All right, so let's rack our brains here for a minute. Does anybody remember maybe an example of an operation? What am I talking about, an operation in math? Okay, what is an operation? Anybody remember? Okay, so here's a hint. So I take a number and a variable, and what connects them together? There's like a space in between them. What could connect them together? Just give me an example. Plus sign, so addition. What else could connect them together? A subtraction sign. What else could connect them? Multiplication or division. Okay, so we have our add, subtract, multiply, and divide. And I'm just going to abbreviate. Okay, so those are our four basic operations. All right, and so you do need to know that that's what we call them, operations. So, that's another term that you might hear. And then simply put, to evaluate means to solve. So if I say evaluate, I mean solve or simplify as much as possible. Okay? Okay, so let's see how this looks in example 1. Okay, in example 1, evaluating expressions. All right, so I've written, this is something that you may see from time to time, or it may even be a habit for you, but we don't use the dot to show multiplication, okay? We just write it 4D. Okay, so we're just going to make our substitution. So you should have already written down on your notes 4D, and then when you make your substitution, you have to think about, okay, what operation is this, 4D? When a number and a variable are next to each other, it's multiplication. So I have to use parentheses to show multiplication, because if I just plug in 120, it's going to look like 4,120. I have to use parentheses to show multiplication when I substitute, and 4 times 120 is 480. So I have now evaluated that expression. Substitute the value and solve. All right, now in the next one, c over 4, when c equals 36, I just make my substitution again. So now I have c over 4. I substitute 36 for c. 36 divided by 4 equals 9. And that's my answer. All right, so now let's look at the next example. Now in the next example, we're just taking it on just another step, and now instead of using one variable in the expression, we're using two variables in the expression. So you have x equals 10 and y equals 4, so just plug in the value for x and plug in the value for y. So 10 gets substituted for x, 4 gets substituted for y, and 10 plus 4 is 14. All right, I want you to try to do B. All right, so when I substitute 10 and 4, what sign do I need between these two numbers? Do I need an addition sign? I need multiplication, but do I use a dot? No, I need to use parentheses to show multiplication. And what's my answer? 40. Did you use parentheses? No dot. Okay, use parentheses, because a dot can be confused for a what? A decimal. All right, So now I'm going to do the same thing over here, except now A equals 40 and B equals 5. I just make my substitutions. 40 over 5, and then I simplify or evaluate. 40 divided by 5 is 8. Now, the next one is a little different. Why? What do you see that's maybe a little different than the other three? Yeah, so there's 2 B's. You see 2 B's. Well, is that really any problem? No, I just plug in a 5 in 2 different places. So I've got 40 times 5 divided by 5. And since it's just multiplication and division, I just work it left to right. 40 times 5 is 40. 200 divided by 5 is 40. Yes. And 40 is my answer. All right, step by step. So everybody good with writing your original expression, showing substitution, boxing your answer? Yeah? Okay. All right, so now I want you to do these checkpoint problems. This is just kind of to recap. We'll take about 5 minutes. X equals 6 and Y equals 12. Go ahead and make your substitutions and solve each one of these. All right, so we've got, yes, we make our substitutions. We get 23, 6, and 72. All right, and that would be our answers. Anybody got all 4 right? Okay, awesome. Great job, guys. Great job. All right, so in example 3, writing variable phrases, you don't have to write down all of the key words. It's actually in your book on page 6. So if you can, instead of copying down the entire slide, I just want you to write in your notes, example 3, writing variable phrases, what I'm highlighting here, right here. And then just write textbook page 6. So in the textbook, it gives you a chart of all of your different keywords for expressions. And this is helpful when we're trying to write what we call verbal models. So we're given a scenario, and we've got to create a verbal model for what it's trying to solve for, calculate, or kind of however you want to word that. So let's just go through some of the common keywords, and you'll probably actually already know some of these. All right, so what operation is connected? Plus. What is that? Addition. Very good. All right, everybody together. What about difference of? Subtraction. What about product of? Multiplication. What about quotient of? Division. What about minus? Total. And times. Multiplication. All right, so you already know most of these. You might just need a little refresher. So where can you find the chart? Page 6 in your textbook, right there. Common words and phrases for operations. All right, now I do want you to write this part in your notes. Exceptions, and flip the order. What does that mean? It means that however you read it, you don't write it how you read it. You're actually going to reverse the order of the terms, okay? And we'll see that in just a second when we do the example. All right, so sometimes if it's more than or less than or fewer than, I actually reverse the order because I'm taking it from some other number. All right, so go ahead and write down those exception keywords: more than, less than, and fewer than. All right, so on page 6, it gives us an example of a baseball league. So let's say, and we do this even here at the school, you know, let's say 120 players, so people try out for the baseball team here at Trinity. 120 players. And out of those 120 players, now the coaches have to figure out how many players are we going to keep on each team? Because how many teams do you normally have in a whole, let's just say, baseball program? No, how many teams would you have? Junior high, JV, varsity, sometimes even a freshman team. So how many players would you keep per team? Well, in all of those scenarios, we're using variables. We're trying to play with the numbers, okay? Well, if we have 120 players, can we keep them all? That might leave a lot of players on each team, right? So we couldn't keep them all. So here's how it looks, all right, creating the verbal model. Okay, so again, we have The number of teams is what we're trying to figure out. How many teams can we have? We know that 120 players are trying out, so we're going to use the variable P to represent how many players per team. How many players per team. So here we've just set up a verbal model. What does that mean? It basically is showing the operation that we have to use in order to get to our answer. We have to divide the total by how many players we want per team, which we don't know currently, to figure out how many teams. So let's kind of experiment with this a little bit. Typically in a baseball lineup, does anybody know how many batters are normally in a lineup? 9. Okay, so there's normally 9 positions in a lineup. So let's just say that he only wanted 1 substitute per team. So that would be 10 players per team. So if I gave P a value of 10, how many teams would there be? Go ahead and substitute. If I gave P a value of 10, how many teams would there be? And how many would it be, guys? 12 teams. Very good. So I make my substitution and I solve. So if I'm the coach and I say, okay, you know, I want to run it kind of tight. I want everybody to get the most playing time as possible. Then I'll put 10 players on a team. So that means I have 12 teams in this league. Okay. But what if I say, well, you know, 12 teams is a little much. What if I wanted fewer teams? How could I have fewer teams but still keep all 120 players? Anybody know? How could I have fewer teams, Lexi?
You'd have 12 players on each team.
Very good. All right, so she knows exactly where I'm going with this. I can increase the number of players on each team, so I decrease the number of teams that I have. All right, so let's give P a value of 12. Let's give P a value of 12. So now I'm going to keep 12 players per team. All right, so how many teams am I going to have now?
10.
I'm going to have 10 teams. All right, so hopefully you can see the relationship here, okay? If I increase the number of players per team, then it decreases the number of teams that I have. And so this is a very practical example of how variables, you can give it whatever value we want. I could give P a value of 20. And if there were 20 players on a team, how many teams would there be? Anybody do the math real quick? 6 teams. All right, so that's where we really can assign P whatever value we want in order to achieve the number of teams that we want to have. All right, so verbal models, that's basically what we're looking at there. All right, so now let's look at something that would be more along the lines of what you would see on a quiz or a test. And you have a section like this on your homework tonight. It says the product of 15 and a number. Here's what you're going to see here. You're going to see a key word in the expression product. Okay, product is my key word. What operation is indicated by product? Multiplication. And then where you see the word and is where you plug in that operation. Remember, the operation connects the number and the variable together. So if it connects it, how would I write this as an expression?
15 times the number.
15 times the number, but do I need a little dot? Do I even need parentheses? Just write it 15n. That's all you have to do, 15n. All right, you don't need a dot between them. You don't need parentheses because a number and a variable together means multiplication. All right, now the next one is a little different because I actually can evaluate this. The difference of 20 and 12. Again, where's my key word? What is my key word? Difference. What does difference mean?
Division.
Oh, subtraction. All right, need a little refresher. All right, so it's subtraction. So I put in the subtraction sign right where I see the word and, connects 20 and 12 together with a subtraction sign. So 20 minus 12 equals 8. 20 minus 12 equals 8. And I actually could evaluate that. I couldn't evaluate the first one because I don't know what n equals. All right, so we're just using those key words to plug them in and connect our numbers and variables. So let's do a couple more and we'll be done. All right, 6 fewer than a number. All right, try to remember what I said about that fewer than. What happens to the order? Let's try to write that expression. And then twice a number plus 20. All right, so what do you think? 6 fewer than a number? Is it 6 minus n or n minus 6? It is n minus 6. Very good. N minus 6. Because, again, it's fewer than, so I'm taking it from the number, so it's going to be n minus 6, not 6 minus n. All right, what about twice a number plus 20?
2n plus 20.
What do you think, 2n plus 20 or n to the second power plus 20? We saw that a lot in one of the earlier classes. What do you think? Who thinks 2n plus 20? Yeah? What did you write? Have you done it yet? All right, so if it's twice a number, think about this, twice a number. All right, so if I said yesterday I spent $10 at lunch, but today I spent twice what I spent yesterday, how much did I spend today? $20. What did you do? You multiplied it by 2. So twice something is going to be double. All right, so I write that 2n and then just plus 20, 2n plus 20. And that's my answer. All right, so just translating these phrases, you've got a couple of these on your homework tonight. And if you understand that, that's everything you need to know for 1.1.